Hello, this short little documentary is on this locomotive here. This is what's called the NB1 locomotive. It was built by Island Pond Railroad. Hey, that's us. Over 10 years ago. So this unit is now over 10 years old and it is still in use for just about everything. We now have 4 locomotives on the roster in various states of completion. 3 are actually runnable. 1 is still under construction. The NB2 is still under construction. We'll do an article on that later. But this is about this one. Looks an awful lot like another product you might have seen called the shifter, but it is not. This is older than the shifter, and in fact the shifter was made from the original plans for this locomotive, which can be found on discoverlivesteam.com. So we'll go ahead and take the cover off of this so you can see what's inside this unit. As I mentioned, it's 10 years old, so it's more than overdue for new paint. But let's take the cover off and see what's inside. Now, as you can see, the shell of this locomotive is made almost entirely of 1/2-inch plywood, very little else. If you look down inside the shell, you can see some recognizable things. The bell, you may have heard the bell in some videos. That's where that comes from. And you most certainly likely have heard the air horn. And you can see the compressor and the air horns mounted up there. And of course the headlights, there's one on each end. The cab controls are accessed through the window on each side. There are some switches down in there that control the direction. And then the horn button is down there. I think that's the headlight side, I'm sorry. The other side doesn't have an opening because the motor doesn't protrude from that side, so we can't give you a similar vantage, but the other switches are done very similar. These are the cab controls for the forward, reverse, and dynamic braking, and then the switch all the way to the right, that's the train line control for the electric train brakes. So the heart and soul of the NB1 locomotive is actually its motor. There's a middle, you can see a 2.5 horsepower 120 volt treadmill motor, but also these big 27M marine batteries. There's 2 of them because the primary voltage going into the controller is 24 volts. You can see that the controller is actually on right now. It's telling me that 2 things. It's telling me I have low voltage and it's in dynamic mode. I'm not sure when I last charged these batteries, but the controller's probably right. It's telling me they probably need to be charged. And then there's some connectors, one that goes to the shell, and then there's a switch down there that turns the whole thing on and off. It doesn't really turn the main power on and off, it just controls a relay. So let's go around to the other side. This particular unit only has one equalizer bar on one side. The NB2 locomotive differs in that regard in that it has an equalizer on each side. I'll show you what the equalization does in a minute. But this is a chain drive locomotive. You can see the chains down in there. Motor drives a chain, drives a shaft, drives a reduction, drives another shaft, and then the final shaft drives the 2 axles. You can only see, 2 chains, the one going down to the input shaft and 1 chain going from the output shaft to the left axle there. The other chain, you can see through the battery there if you look carefully, goes to the other axle. This basically has the same gearing as the F7 locomotive. This drive is identical to the F7 in terms of reduction, number of chains, number of sprockets, etc. So we're going to go ahead and put this up on blocks so we can run it and show you the equalization. Okay, I have a test plug which is plugged into the controller. It allows me to actually operate the locomotive with the cab removed. Basically it's the same 4 functions that are available inside the locomotive. And I was going to point out, get some of the leaves out of here. The Equalizer Bar In a real locomotive, there would be one on each side of each truck. Well, we only have one truck. No, we have two single axle trucks. Truck there, truck there. And the equalization works by very simply taking, when it hits a bump, one of the wheels lifts and it takes the weight from that wheel, puts it on the opposite wheel. So it really doesn't matter what kind of shape the track is in, as long as it's holding gauge, it'll still stay on the track. Very, very simple equalization. Now the NB2 locomotive being double, it's a completely different setup. You'll see that instead of having two single axle trucks, it has one two-axle truck. Same principle though, and one of these days we'll do a video on that once we get it completely operational. Now the controller on this locomotive is a little bit different than what a lot of people are used to. Most people are used to just buying an off-the-shelf Joe's special controller, whatever. Doesn't work here. We have a 24-volt voltage source, two batteries, and we have an 120-volt DC treadmill motor. So somehow we have to get from 24 volts up to as much as 120 volts DC. Obviously, when you're going slower, you don't need that much voltage, but when you're at full throttle, you need the full 120 volts. So we're going to open the controller part and show you what that looks like. I'm going to power this down first before doing that. So I've removed the first cover, which is basically just removing this chassis from the top of the box that contains all the power electronics. And inside here it's pretty simple. There's just a circuit board there with an off-the-shelf Atmel microprocessor. And a few logic chips and some comparators, various other stuff. This sits on top of a steel plate. Yes, the steel plate is required because that's the magnetic shield between the sensitive electronic stuff and the high power stuff that's inside that box. Now inside the second cover is a completely different story. There's nothing simple about this. Inside it is all the power electronics. You see a large silvery round object about 5 inches diameter down there in the bottom under all those wires. That's actually a transformer. It's a 1,000-watt transformer. It's primarily responsible for increasing the voltage from the 24-volt range up to about 96 volts. And then 100 volts is obtained by adding the battery 24 volts to the 96 volts. There's some big transistors in here. They have to handle the current required to drive this transformer. And then there's some relays that are used mostly for directional control and that sort of thing. And then there's a big resistor in there somewhere. I don't know if you can see it or not, but it's used partly for the dynamic braking. Most of the dynamic braking takes the energy and puts it back into the battery, but there's a certain part of it that in certain modes you just can't do that. Anyway, like I said, pretty complicated box, and I don't get in there unless I absolutely have to. Okay, so I powered it back up and the low battery light has gone away. I guess that's a good thing. And put it under load though, it'll come back. And don't have any way to do that without sitting on it. I can go ahead and operate the thing. Today's mission is really to apply some chain lube. As with any chain drive, you have to lubricate it, otherwise it doesn't last very long. So I use this Teflon chain spray. This works really good, I like it. If you don't lubricate your chains regularly, you end up having to replace the sprocket that moves the fastest, which is the motor sprocket. The other ones don't seem to matter so much. Fastest moving one wants to wear out. This is the third motor sprocket that I'm on. Alright, let's see if I can get the back, some of the back ones. Going after the rear axle chain. And also the crossover chain. Really hard to get to. Okay, so we got all the chains lubed and got the cover back on, and it's all ready to go. So the only thing left to do is just to check out some of the functions, make sure that they still work, like the bell. And then let's see, what is this one here? Headlights. That one works. Yep, that one works. And then, okay, the only thing left to do is to get on and see if we can actually make it go.